The operating principle of this wave power station is as simple as it is ingenious. An enclosed chamber has an opening beneath sea level, which allows water to flow from the sea to the chamber and back. The water level in the chamber rises and falls with the rhythm of the waves, and air is forced forwards and backwards through the turbine, connected to an upper opening in the chamber. As it is compressed and decompressed, the airflow has sufficient power to drive the Wells turbine. It is a feature of the Wells turbine, named after its inventor, that it is driven in the same direction by both forward and reverse airflow through the turbine. Even relatively low wave motions can generate enough airflow to keep the turbine moving and to generate energy. This is how easily energy can be generated with a wave power station, day and night, all year round, as long as there are waves.
One concept for harnessing the wave energy is the oscillating water column principle. The power takeoff for this technology is typically an air turbine. The most commonly used air turbine for this application is the Wells turbine, which we will explain in this episode. The water level in the chamber rises and falls with the rhythm of the waves and act as a piston. The air is forced forwards and backwards through the turbine and causes the rotation of the turbine. This generates mechanical energy that is converted into electricity by a generator. The Wells turbine has a special feature: it always rotates in the same direction, regardless of which direction the airflow comes from. How is this possible? This is feasible because of the symmetrical shape of the rotor blades. As the air hits the rotor blade, most of the flow is deflected in one direction and pushes the blade in the opposite direction. Due to the symmetrical shape of the rotor blades, the same effect happens when the airflow comes from the other direction. Therefore, this Wells turbine always rotates in one direction, regardless of the airflow direction, and guarantees the continuous rotation of the turbine. The Wells turbine must be turned on initially, the airflow alone does not get it to rotate. This turbine is one of the simplest turbines for wave energy conversion. It has very few moving parts. None of them are in the water, need no gearboxes, is easy to maintain and achieves an efficiency between 40 and 70%. This turbine was tested in several research plants under real conditions. Limpet. The power plant on the Isle of Islay was the first commercial plant in operation between the year 2000 and 2018. It generated 500 kilowatts with 2 Wells turbines. The Mutriku breakwater wave plant in Bay of Biscay on the coast of the Basque Country in Spain, started in 2011. It has 16 Wells turbines and supplies 250 households with energy. The Wells turbine has the most operational experience and running hours of all air turbines for oscillating water column concept of harnessing the wave energy, and it makes a small contribution to the generation of sustainable energy.